Hello, everybody. We're continuing on our environmental theme. 2 or 3 weeks ago, we had the great Bill McKibben on the show talking about the sun. It's a last chance for the climate, he said. I titled our conversation, Move Fast and Fix the World. Here comes the sun in the nick of time, and it very much is the nick of time, according to McKibben. Although he's unusually optimistic given his history, given the bleak forecasting he's done in the past. And it was interesting, in my conversation with McKibben, Peter Brannen came up. His book, The Ends of the World, was a big success. And he has another book out right now. It's called The Story of CO2 is the Story of Everything. Peter Brannen is another environmental writer. He is a contributor to The Atlantic, and as I said, the author of two particularly interesting books. Peter is joining us now. Peter, it was interesting that when Bill was talking about the optimism, I brought you up, and he kind of smiled half sadly, half enthusiastically, and said, well, I guess to excuse the pun here, the glass is half full. Is that fair?
That does seem like a fair appraisal of the situation. It's funny. I've read about his most recent book, and it does seem like there's all these like very encouraging trends in the world of solar that are really accelerating and do sort of give some reasons for optimism. But I guess I see part of my role as kind of to flag that we still kind of are leaping into the unknown in terms of what we're doing to the atmosphere and the oceans. And there are these scary analogs in Earth history that hopefully the fossil record provides to us so we can learn just how far, if you keep going down the road that we're going currently in terms of CO2 emissions, you can see just where that road leads. And we know from Earth history that sometimes it gets pretty grim. So I think it's worth keeping in mind that there are encouraging trends, but we really are operating without a net. And the sooner we, get off this carbon-based global industrial economy into some other sort of more sustainable source of energy, the better. So I guess that's where I would.
Well,
thanks.
That's pretty bleak, Peter, because in the sense that it's all very well saying that, and I don't necessarily disagree. I mean, I'm not an expert like you are, but the idea of us, to quote you, getting off our current industrial economy seems, unless there's a catastrophe, seems highly inconceivable. Let's get to your argument. Sorry, the argument in CO2. But before we get that, maybe you can respond to what I just said.
Yeah, no, I'm not saying that we should ditch the industrial economy. I'm saying we need to power it with a equivalently scaled power source as currently fossil fuels are. Because I agree. I don't think you do have these proponents of degrowth where it's just we need to ramp down GDP.
Hickel, a lot of those guys, Tim Jackson and Hickel have been on the show, and they make a good case, but it's just not very realistic.
Yes, yeah. I just don't think it's feasible or politically saleable.
Yeah, unless there's a disaster. So how does Bill's argument about, I know you haven't read the book, but you can imagine what he says about solar power, which is a positive argument, and your story of CO2, which you say is the story of everything, is a negative argument. How are they connected? How does CO2 and the sun, how do they interact? Or is the problem that they don't interact?
Well, I mean, the encouraging thing is that the price of solar panels has drastically plummeted. And it seems like there's indications that, maybe this is all just like superior technology and the US is just going to get left in the dust if everyone else goes to EVs and clean energy. The thing that I like to keep flag is that China currently, there's that happy story, which also has its complications because of the labor that they use, and it's Western China and it's fueled by coal. But leaving that aside, it's good that they're making genuine technological advances in solar. They're also burning 4 times more coal than the United States ever did at its peak. And CO2 emissions are still going up from their almost geologically unprecedented level every year. Some people think that'll plateau at some point. And in order to get analogs to that level of carbon emissions in Earth history, you have to go back hundreds of millions of years to these really scary chapters. And so, I mean, in my book, I point out that basically every power source we use is solar powered. So fossil fuels are basically just the energy of the sun that's locked up in carbon compounds. Plants take in CO2. We're all carbon based, and the source of that carbon is CO2 that originally enters the biosphere through plants and photosynthesis. Some of that plant life gets locked away, and we dig it up hundreds of millions of years later and burn it all at once and put all that ancient CO2 over 500 million years into the sky all at once. And that is like such an unprecedented experiment that we're running on the planet.
And as you note, I'm quoting you here, everything about this epoch is superlative, bizarre, unprecedented. So before we get to those consequences, just very briefly, because not everyone listening or watching, Peter, will of course have your scientific knowledge. What exactly is CO2, and why do you argue that it's the story of everything?
I mean, it's the second most abundant gas that comes out of volcanoes other than water vapor. And it has these two unbelievably important attributes that I argue make planet Earth. One is that it traps heat on the surface of the planet, which is actually a good thing, because if there was no CO2 into the air, there's one simulation that within a half century, the temperature would drop by 35 C, or whatever that is, 60 degrees Fahrenheit within that time span. You'd probably get glaciers going all the way to the tropics, and it would kill all animal life on Earth. So it's good that there's some in the air. But it's this really narrow window you have to navigate, where if you get too much, Venus has 99% CO2 or something like that, and it's this uninhabitable greenhouse. So if you get too much, and this happens occasionally in Earth history, where too much CO2 gets erupted from volcanoes all at once, and it makes it uninhabitably warm and causes mass extinctions. So there's this very narrow window you have to navigate to keep the planet habitable. And so it's good that there's some CO2 in the air. The other amazing thing about it is just that it is literally the substrate of all life. All life is made out of carbon, as I said before, and the source is CO2. So it's both makes the planet habitable and inhabited by having those two features. So that's why the point of this was, people hear about CO2 in the news as this thing that just so happens to come out of smokestacks. And coming from the geoscience, earth science world, I really wanted to reintroduce people to it as, not just some random industrial pollutant, but it is like fundamental. Its behavior on planet Earth is what makes Earth Earth. And this is one reason why you don't want to mess with it too much, because it's so important.
Right. So just to be clear, CO2 is both the natural product of the Earth, as you said, it comes out of volcanoes and other natural sources, but it also is a consequence of the Industrial Revolution. Is that fair?
Yes. So, we're animal life, and all animal life burns carbon in our diet that originally was made by plants, or things that eat the things that eat plants. And we use oxygen and we burn it and we breathe out CO2, and that powers our bodies and our lives. And what humans have done is sort of this freakish version of it, where they've found all the exact same chemical reaction. We found all the life buried over all of Earth history in fossil fuels buried in the crust, and we're burning it with oxygen and producing CO2 to power societies, just on this scale that's totally unprecedented and faster than the Earth can accommodate, through these natural sort of cycles that I talked about.
Yeah, and you got another great quote, and I apologies if I maggle this word, the late Neo-Proterozoic world was quite literally a different Earth. So the Earth we've created, I guess, with the volcanoes, is just an entirely different phenomenon. So essentially what you're saying is we're tipping the CO2 balance. Is that right?
Yeah. And so the excerpt that you're pulling up there is actually from one of the earlier chapters. And in that, I'm talking about this very ancient climate change catastrophe called Snowball Earth that happened in the Neo-Proterozoic. So that's what that's a reference to, where, as I indicated before, the planet can like totally freeze over, and that's what happened then. And it wouldn't have resembled Earth at all. What we're doing today, yeah. So like I said, it's good that CO2 comes out of volcanoes. If it didn't, none of this would work. The planet wouldn't be warm enough to survive, and there wouldn't be any plant life because there would be no carbon in the air. So that's a good thing. But normally these things cycle. They, goes out of volcanoes at a rate 1/100th that we're putting into the atmosphere today. but at this much lower rate that the planet can accommodate, and it goes into the air and oceans and through life, and then eventually back into the crust and then out of volcanoes again. But this cycle takes place over hundreds of thousands to millions of years at a rate that the planet can accommodate. And what we're doing is we're just putting so much into the air all at once that it overwhelms these natural processes that remove it. And if you're doing that, then it's not being removed and you're just spiking the temperature. And life is very adaptable and can bend and adapt, but at a certain point you can surpass a speed limit where life just can't migrate fast enough to keep up with the warming, or the ocean's going to acidify, which is what happens when CO2 reacts with ocean water. So it's a good thing that CO2 is in the Earth system. It's just what we're doing is not sustainable. And as you said, yeah, it does tip the balance.
Right, and in your piece, you asked what would happen if all the ice on Earth suddenly melted. I don't think any of us want that to happen. It's interesting you talk about the speed limit, Peter. We did a show last week about what one author called Big Car, suggesting that cars are essentially destroying the Earth. In terms of all this extra CO2 in the atmosphere that's tipping the balance, is it mostly because of automobiles? Is it industrial production? Is it the burning of coal? How does it break down?
I don't have the exact breakdown. I think transportation, I think, is like 20% of emissions maybe, but I don't have the exact numbers on me. A lot of it is just industrial activity. You have power plants, you have heavy freight and shipping, cement making is a huge contributor, steel making. Basically, all the sinews of industrial civilization are using the biggest energy source in Earth history, this huge store of energy from underground, to power themselves. And we need to hope that we can switch that out in a matter of decades to this new source that, if you talk to people like Bill McKibben, they're very optimistic that we can actually do this. And if we did, it would be one of the most remarkable things that's ever happened in Earth history. Switching in a matter of decades to this completely novel way of powering.
It would speak highly of us. We can begin to think fondly of ourselves again. What about the issue of nuclear power? We've done some shows on that. Isabel Bermenke, a Brazilian nuclear energy activist, argues that ultimately this is the thing that can save us. Do you have any feelings on nuclear? She told me that I was a bit of an old fart because I collapsed the issue of nuclear power and nuclear energy and nuclear war, which I don't think are the same things, but people have always been fearful of that. Are there certain kinds of energy that you're more or less sympathetic with in terms of your argument in the story of CO2? Is it nuclear? Is it solar? Or maybe something else?
I think it's a combination of everything. I think you will talk to people who are advocates for certain power sources and they'll be all in on one, but there are advantages and disadvantages to each one. So when I've talked to my parents are more freaked out about nuclear than I am because they're older than me, and they remember living under that umbrella of, nuclear being a somewhat scary thing, but it does provide carbon-free, firm baseload energy, which is different than how solar provides energy, unless you add batteries, which can be expensive. So I'm not a grid necessarily person. It just seems like we're going to need all approaches to fix the problem.
There are lots of arguments or lots of examples of people trying to, bury or reproduce or reinvent CO2. There was a piece last week in Forbes about how one company is turning CO2 into the building, I'm quoting the piece, the building blocks of everyday products. There are a lot of startups, particularly in Silicon Valley, that think that they can be successful and do good at the same time. Are there some examples of technologies which are confronting the problem that you talk about? I know in Singapore, there's a facility that's just been opened to remove ocean CO2. Are these for real, or are they PR operations by governments and private companies?
It's a little bit of both. So I know some incredibly knowledgeable and intelligent, brilliant geoscientists and earth scientists and chemists and things who work on CO2 removal, and they will not, they're under no misimpression about what sort of scale this can contribute to getting rid of CO2 in the atmosphere. This might help in the long run when we have difficulty decarbonizing certain parts of our economy. But if we don't drop carbon emissions immediately to almost nothing, then these are basically useless technologies, because it's just impossible to scale up CO2 removal at the scale that you would need to. And that's not me just being a skeptic. It's like there's physical thermodynamic reasons why it's very hard to sweep up a very diffuse gas in the atmosphere and bury it somewhere. That's always just going to be a very energy intensive activity. So I know a couple of these stats off the top of my head that in order to reverse warming by 0.1 degrees C with direct air carbon capture techniques would cost $22 trillion. And I think 2 years of global electricity use or something. And that's under a very rosy scenario where it's pretty cheap. Right now, we haven't gotten it that cheap. So in the long run, there's too much CO2 in the atmosphere as there is, and this stuff only accumulates. So in the long run, once we drop our emissions to zero, we still need to get rid of some of it. So some of these technologies might mature and help us with those residual emissions or get rid of the fact that we've already emitted a lot. But you can't keep putting it into the air at the same rate we're doing it and remove it at the same rate. So I'm impressed and inspired by people who are working on the problem, but they are not misled about the how much it can scale up to help us with our problems.
So some of those stories, they seem to have disappeared now about burying CO2. I think there were some initiatives in Norway or Iceland. Is that another? I mean, it's a feel good story, but it's not for real in your view.
Well, one thing I really like about that technique is that it does build off this legacy of earth science and deep time and geology, in that, as I was saying before, the earth has these ways over very long time spans to get rid of the CO2 in the atmosphere. There's this thing called rock weathering, which is what it sounds like, which is when too much CO2 comes out of volcanoes and it gets warm, the CO2 reacts with rainwater and it reacts with rocks. And eventually that carbon from the air goes into the oceans. And on the long term, it becomes limestone at the bottom of the ocean. So all the CO2 we're putting in the air right now, someday, hundreds of thousands of years ago, or hundreds of thousands of years from now, it's going to end up as limestone on the bottom of the ocean. That just takes too long for it to help us out in the short term. But what companies are doing, like the one in Iceland, is they're accelerating that process by hundreds of thousands of years by injecting it straight into the rock there and basically turning the rock into limestone right under their feet. The problem is Iceland is incredibly good to do that. And there's only a few places on Earth that are really advantageous for that sort of carbon burial. So again, this is a technique that could help us out among this roster of techniques and things that will help us get us there. But whenever you read a headline that says this is the one that's going to save us, you can just automatically kind of temper your expectations about how much it can.
Isn't that one of the problems, Peter? Your the New York Times review of your book, which was a very good review, headlined "An Environmental Villain Reconsidered," because, as you note, CO2 is both the good and the bad guy in this story. But it's one of the problems that we humans, maybe we're wired that way. Maybe we've been watching too many Hollywood movies. But we're always looking for the good and the bad guys in all this stuff.
Yeah. And it is a subtle story. It is more complicated than that. And there's a reason why fossil fuels were as useful as they were for as long as they were, and that we are finding it very hard to get off of them. Like, I think there's this common trope that, we're only burning fossil fuels still because you have these mustache twirling CEOs at places like Exxon and private oil companies. But it turns out that most of the oil on Earth is owned and produced not by private companies, but by sovereign governments. And in some places like Norway that we think of as sort of very kind of enlightened places, they still are exploring for oil and investing in geological exploration because it's just too profitable to
Bill
to burn the
talks
stuff.
about that, and he didn't call them the enemy, but the way it comes across is that lobby is so strong, it's very hard to fight.
Yeah, it also is just like still the most profitable product on Earth. And if you're a government and you want to maintain your, foreign exchange and have a sovereign wealth fund, it turns out the vested interest in finding this stuff and selling it to people it's very hard to kick that habit.
One of the I mentioned that we did a show on big car with a Santa Barbara-based writer, David Obst. He doesn't have your scientific credentials, but he's quite a character. We talked about electric vehicles, and I said, well, isn't that the answer? He's against all cars. He thinks cities should ban cars, which, again, I'm not against, but I'm not sure how realistic it is, particularly in the US. And we talked about batteries, and his argument was that batteries ultimately are as problematic in environmental terms as gasoline fuel cars. Now he's just focusing on electric vehicles. But what's your sense of the electric powered revolution? Are there problems when it comes to CO2 and this crisis of the earth? Are batteries as much of a cause as the solution?
No, not in terms of CO2, but I do make the point in my book that you could totally decarbonize the world, and that does not necessarily entail building out like a just or a good world necessarily, because right now a lot of the minerals that we use in the renewable world are things from like cobalt from the Congo, which is mined in these
we've done a show on red cobalt, on the environmental and humanitarian and political consequences of that. And of course, the Chinese investment in Africa in itself is complicated and controversial.
Yeah, so you have these, appalling working conditions in certain places. And yeah, I think there might be a little too much dismissal from the environmental world about just how much copper we're going to have to mine, and the fact that we've been mining copper for 6,000 years. So the ore grade is not very high. So you need to process a lot of rock to do that. And no one wants a copper miner in their backyard. And, they might not put gigatons of CO2 into the air, but they do leave gigatons of tailings and waste and things. So these are, I think that the clean energy world should confront these facts a little more, but I also just don't think there's any alternative, that we're going to have to do this. And the only way to make it, a just transition as well is to, some sort of pie in the sky, more democratic decision-making about where these things are going to be placed on Earth, and, who's going to be footing the environmental bill. But that's one reason why you can be skeptical of, like, if you're just arguing for we just need to replace all cars with electric cars, then yeah, that you're still inflicting a pretty heavy blow on the natural world. What we should be doing is, I guess, increasing public transportation and things like that, and minimizing car use, while switching it over to a clean energy world, if you really want to, check all those boxes. So it's a difficult problem. That's one thing I want to underline. It isn't just, tomorrow we could wave a wand and everything would be better. We're so far down the road now of climate change and what we're going to have to pull off, that there's no easy solution. And we really need to confront how difficult that's going to be.
Yeah, and it's not easy for America. Some people seem to think all America needs to do is become Denmark, turn all our cities into Copenhagen, or Norway, as you noted. Even Norway has a checkered history. What about the climate skeptics? Peter, someone might be watching this and saying, well, this guy doesn't seem entirely clear. He talks about limestone, really, really long-term consequences. He has no idea of the long-term consequences. Why worry about this? The science is still, to some extent, undecided, and the long-term consequences are always more confusing and problematic than we think.
I would say the science is not the jury's pretty in on, it's going to be pretty disruptive and bad, even in a best case scenario. And the worst case scenarios we don't really have a good handle on, because what we're doing is kind of unprecedented. And, and I usually write about these ancient periods deep in Earth history. And sometimes I'll get the climate skeptic sort of refrain, where they'll point out that, 50 million years ago, CO2 was a lot higher than it is today, and life was pretty happy. So what's the big deal? And that's true. But 50 million years ago, CO2 was what it could be next century in like a pretty bad scenario. and there were crocodiles and palm trees in the Arctic Circle, and sea level was a lot higher, and the mid latitudes and tropics would have been totally uninhabitable to mammals like us. And so the problem with using an analogy like that is that life had tens of millions of years to adapt to this very hot world that is totally outside of our realm of experience. And suddenly launching our world, which is actually relatively cold compared to Earth history, where we have ice sheets on, Antarctica and stuff, into this alien greenhouse from, the age of dinosaurs in a matter of decades, that you don't see changes like that on Earth that rapid almost ever in the entire history of animal life. And when you do, it's associated with really big mass extinctions. So I draw most of my kind of worry from this helpful experimental record in Earth's past, showing you what happens if you keep going down this road much further.
But it wasn't.
So I know that's what's, yeah.
It was the natural forces that corrected that. This time it requires us.
Yeah, I mean, what saved the world then was, after hundreds of thousands of years, these long-term processes sequestered the CO2, and that's going to happen again for us too. But we don't get to live on our lives on 100 millennia timescales, and in the meantime, it's going to get really hot and unpleasant if we don't change what we're doing.
So, how would you like? You're, as I said, you're a contributing writer to The Atlantic. You're the author of two important books: The Ends of the World, and your latest, The Story of CO2 is the story of everything. You deal with these stuff in complex historical and scientific terms. One of the problems, I think, with the way in which the environmental stuff is reported is there is a degree of hysteria every time you hear about an ice sheet in Antarctica or the Arctic melting. Everyone thinks it's the end of the world. How would you like the reporting on this to change, or am I wrong?
I mean, I'd agree with that to some degree. A lot of these, question, how fast, what's the response of ice sheets going to be? You'll get a study some week saying that it's going to be much faster than we thought, and then you'll get some study a few weeks later saying, oh, good, well, this mechanism might not actually come into effect for centuries. So, like, the sort of reporting that jumps on every story as this is the scariest thing ever, science doesn't really work that way. It sort of triangulates and slowly comes to this consensus. All we do know is that eventually, if you keep the planet at, a couple degrees warmer than it is today, all of Greenland's going to go, and the entire West Antarctic ice sheet's going to go. That might take, different estimates might be by millennia. So because we're jumping into the unknown, as I said, we're pushing on our system as hard as we can. And so trying to figure out what's going to happen is very difficult. And just keeping your eye on sort of the prize that, we don't know how the Earth is going to respond. So we should use the precautionary principle, which is, given that the tail risk is so high, we really should act with as much urgency as we can, even if it is unknown, what we're doing.
And of course, the latest new thing in technology is AI, which requires more and more power. Google just invested in nuclear power. Many of the other big players, OpenAI, are also investing massively in energy. So this problem is only going to get compounded in our AI digital age, isn't it?
Potentially, yeah. I mean, I don't see any slowdown in human energy use in the next few decades. And although I am a little skeptical of some of those graphs that are straight lines up for energy use for AI, because I don't think the productivity miracle that AI is promising is coming anytime soon. And you can't just keep burning billions of dollars every quarter on this thing that is, right now, for the most part, unprofitable, other than cheating on college papers and other kind of marginal uses.
So you didn't use it for to help you write the story of CO2?
Oh yeah, this entire book's written by ChatGPT. I didn't contribute.
And even you are a bot, aren't you?
Yeah, that's a joke, just in case someone cuts that one part.
Well, I think we all know that's a joke, Peter. What about when it comes to politics? I mean, the US is notoriously bad because of its, some people would argue, its democratic politics, others because of its dysfunctional government. The Chinese government, when it's come to environmental questions, have a much better press, perhaps fairly, perhaps not, particularly when it comes to solar power. McKibben talked about that. Are you confident that given the democratic nature, the increasingly dysfunctional nature of American democracy, that the American style democracy can actually confront this crisis, maybe in contrast with the Chinese model of enlightened authoritarianism or relatively enlightened authoritarianism?
Well, I don't think you can survey the headlines these days and see any reason for encouragement about the U.S. government's ability to confront this issue. I guess I just try to console myself a little bit by thinking, okay, maybe these are just the death throes of a certain segment of boomers who, the fever's breaking and it's unpleasant to go through that. But if China just leaves, the U.S. in the dust and we're buying all of our stuff from them in the coming decades, I think we'll have no choice but to eventually adopt these technologies and try to make them here as well. So I think the optimistic story is at a global level. If you're going to tell an optimistic level, it's not at the U.S. scale. Right now, it's not encouraging to be an American citizen and care about the climate issue.
What about the international treaties? Again, it's for outsiders or non-specialists like myself, it's very confusing. But America generally gets a bad press. Under Trump, they've pulled out of a lot of the deals, the Paris deals, and etc. In terms of addressing this as a species, because it is a species-wide problem, it's not just limited to one geography or another. Does it require substantial and transparent international agreements that will limit nation states? Because they're not going away in the 21st century.
Right. I think in the long term it will, but again, there's not a lot of reasons to have a lot of faith in those institutions. And so in the short term, I think the optimistic case is just that technology is just going to be so superior that countries aren't going to have a choice but to adopt these new technologies, because it doesn't seem like these international treaties have been very effective. They still get held in countries that are petrostates, and the language always comes watered down, and then we miss the goals anyway. So yeah, I don't really pay that much attention to the various COP. I don't know what COP we're up to right now, but those international
18 or 19. The last one, ironically enough, was in the Gulf, of all places.
Right, and they always issue these mealy-mouthed kind of press releases and things like that. So I don't have a lot of faith now in those international sort of things. I just think it's going to come down to the technology.
So you're making me miserable. I thought you were going to cheer me up a little bit, Peter. I mean, your New Scientist review came with the headline of describing it as a rousing call to action. But if that doesn't work on the international front, are you saying that the rousing call for action should be then on the technological front? Because you seemed ambivalent about some of these initiatives about turning CO2 into burying it or recycling it in some sort of way. Where's the technology? What exactly is our best bet here?
That solar gets really cheap and battery storage gets really cheap. Carbon dioxide removal is never going to work. I'm kind of skeptical about international meetings trying to address it. But at the national scale, yeah, I encourage people to, do all the political organizing they can to push their, municipalities or states or even nationally towards these new energy systems. So I'm not totally, pessimistic. And in fact, I'm less pessimistic than when I wrote the book. I would rewrite the last chapter where I do make this sound like an impossible push to decarbonize the world. And even in the last year or so, the things that Bill McKibben writes about with solar have gotten a lot more encouraging. It seemed a lot more difficult a couple of years ago. I didn't know, how much level of sacrifice it would take to decarbonize the world. And, if it's true that it's just delivers more energy to capture it from the sun and deliver it to industrial equipment and cars and things, and it's just, better technology than fossil fuel, then that, I don't know if that was true a few years ago, and now it seems like there's a case for that at least. So I think people would normally call me a pessimistic person, or at least like realist in this kind of downer kind of way. And the fact that I'm even making these somewhat, noises of green shoots and things, I think is a good sign.
Yeah, we're just another writer from Cambridge, Massachusetts. Finally, leaving aside the big picture, big government, international organizations, scientific breakthroughs, does it make any difference, Peter, what we do? I mean, we've had so many shows on. Does it make any difference if you drive an EV or recycle your vegetables or not drive to the shops or not take an aeroplane? Is there stuff that we as individuals can and should be doing here, or do we just leave it up to the scientists to fix this one?
Well, I think the focus on consumer changes was actually a strategy that was pushed by fossil fuel companies at first, where if you turn your lights off for a few seconds, you're not really saving the world. But it is important to, I guess, create demand for things like EVs. And when I'll get a question, and I'm not really, again, my book is mostly about all of Earth history and this descriptive sort of explanation of how the Earth works and what this thing does on the planet. And I've never been very good at the prescriptive stuff, but I'll always get a question where people say, "Okay, what do I do?"
Those are the questions that sell. That's what everyone wants to hear, really.
Yeah. And it's almost not worth thinking about it as this overwhelming cosmic problem because, one person can't change the world or solve this. But in order to decarbonize, we're going to need all of these skills, things like electrical engineering and welding and things you don't think of as, climate jobs. But if we're going to rebuild the grid and do all this grand industrial policy, we're going to need absolutely everyone who can do any sort of industrial skill there is, along with the political organizers and the climate activists, all that stuff. So I think if you're worried about the problem, you should find the specific lever or pressure point that you can actually apply on it, and not sort of get too overwhelmed by the big planetary.
Well, I think if you're really worried with the problem, you need to read Peter Brannen's new book. The story of CO2 is the story of everything, how carbon dioxide made our world and may indeed break our world. Wonderful conversation, Peter. Appreciate your honesty. May not always be cheerful, but it's important to be, I think honesty is more important than cheering us up. Congratulations on the book. And as I always say at the end, sometimes I mean it, sometimes I don't. This time I really mean it. This one isn't going away. So we'll get you back on the show to find out whether we really are addressing our CO2 crisis. Thank you so much.
All right.